Okay, Kshitij, I will come to the module question that you have asked. Okay, first just try out this question. Okay, so anybody got the first part? So I'll just give you a hint what you have to do for the first part. As the particle starts from here, let's say this point is E with initial speed 0. By the time it comes to this point B, its speed has become V. This angle is theta. So A to B, first apply work energy theorem. Okay. So the change in kinetic energy of the particle plus change in gravitational potential energy should be 0, because work done by normal reaction is 0. As you know, normal reaction always acts perpendicular to the instantaneous velocity's direction. So the work done by it is 0. So at any point of time, normal reaction is acting like this, and the instantaneous velocity is tangential. So your ds is also in the tangential direction. So n dot ds integration will be 0. So work done by normal reaction is 0. So A to B apply work energy theorem. So if this height difference is h, you will get the relation that half mv square minus mgh is equal to 0. This sort of relation you will get. So your v as a function of theta, it become like this. Okay, so that's one thing. Now the other thing is to find normal reaction for n as a function of theta. What you do is you make the free body diagram at the point B. Okay. Make the free body diagram. Remember, it's in circular motion, so it has a combination of radial and tangential acceleration, or a combination of centripetal and tangential acceleration. Okay, so let's look at the second part, the free body diagram, which will help us understand normal reaction as a function of theta. And from that, we can see how it loses contact at the point. Yeah, got the answer? Yes, that's correct. Very good. The Antreshu answer is correct. Very good. So when it is at this point, the forces acting on it are weight and normal reaction. And as you can see, this is the tangential axis, this is the radial axis. So this angle was theta, so this angle is theta. And because it has a speed v, it has a centripetal acceleration of v square by r. Okay, so that is going to be, from here you substitute the value of v square. So it is going to be 2g into 1 minus cos theta. That is your centripetal acceleration. And tangential acceleration we have to find out. Okay, so now resolve the forces in the centripetal direction. So you have mg cos theta, sorry, mg sin theta is the tangential component of mg, and mg cos theta is the radial or centripetal component. It's pointing towards the center of the circular motion. So the centripetal acceleration is pointing in this direction, and the tangential acceleration is pointing in this direction. So centripetal force is becoming mg cos theta minus normal reaction. So that should be equal to mass into centripetal acceleration. And tangential force is mg sin theta, and that should be equal to mass into tangential acceleration. So substitute this value here. So from that we'll get the normal reaction. So as you can see, your n is becoming mg cos theta minus 2mg into 1 minus cos theta. So the normal reaction has a magnitude of mg into 3 cos theta minus 2. This is your normal reaction as a function of theta. So this is normal reaction as a function of theta. And earlier you had v as a function of theta. This was your v as a function of theta. Okay. So now using these two values, you can find out the angle theta at which the contact is lost. And from that you can find the speed at which the contact is lost. So you can work out the second part of the question. That is, find out theta at which the particle loses contact. So we'll also find out the speed at the instant when contact is lost. Okay, so next step, as you can see, is very logical. We have got the normal reaction as a function of theta, and we want to find out at what situation or what value of theta the normal reaction becomes zero, because it loses contact. So at the instant when the particle loses contact, what will happen is that normal reaction will become zero. So theta will become such that cos theta is 2/3. Okay, so this becomes our answer for theta. Yes, Prince, that's correct. Okay, so if you use a cos inverse table or a scientific calculator, you can see that cos inverse of 2/3 or 0.67 approximately is cos inverse is about 48 degrees. So theta is going to be nearly 48.2 degrees, a little bit more than 45 degrees. And the speed at which it will lose contact. So for that, you have the work energy relation, that V was equal to square root of 2 gr 1 minus cos theta. So substitute this theta over here. So it becomes square root of 2 gr into 1 minus 2/3. So this will become the speed at that instant. So I had given the radius to you to be 20 meters. So 2/3 into 10 into 20. So 20 by root 3 meters per second. Or this will be the speed at the instant when it loses contact. So hope this question is clear to all of you. Now let's look at another type of example involving vertical circular motion. So this time we have this light thread which is fixed at this point P, such that it can go around this. And then there's a particle of mass m attached on this other side. It can rotate about P in a vertical circle. Particle of mass m attached the other end. Now initially the particle is given a speed of v naught at the bottom, and the length of the thread is L. So given that the length of the thread is once again 20 meters, it's an easy value to handle, and g is equal to 10 meters per second square. In fact, let's take L to be 10 meters this time. first part, we have to find the tension in the thread we have to find the maximum and the minimum values of tension in the thread and the maximum height the particle will achieve from the initial position if V naught given is 30 meters per second at the initial position. And second, if V naught given is 20 meters per second at the initial position. Just try this out with me. So I'll just remind you of the important concept set here. Whenever there's a thread involved, remember your critical velocity for completing vertical circular motion is root 5 GL. That's an important value to remember. So if your V naught at the bottom is greater than equal to root 5 GL, then accordingly what will happen is it will complete the vertical circular motion, because it reaches the highest point with a speed V of greater than root GL. And if that happens, if the speed at the highest point is greater than root GL, then the string is still taut here because tension is greater than equal to 0. Okay. So for V naught exactly equal to root 5 GL, V is equal to root GL at the top point. So tension is equal to 0 at the top, but tension is greater than 0 for all other points. Okay. So the particle completes the vertical circular motion. For V naught greater than root 5 GL also, there is no problem, because then V at the top is greater than root GL. So tension is greater than 0 at the top. So again, it completes vertical circular motion. The problem occurs if the V at the bottom, that is V naught, is less than root 5 GL. So for that also, as you know, there are two cases. If V naught is less than root 5 GL, but at the same time greater than equal to root 2 GL, or in fact, let's take greater than root GL, root 2 GL, then what happens in this case is that the string will become slack at some point after crossing the 90-degree angle. After crossing the 90-degree position, at some position here, what will happen is that the tension in the string will become 0. So the string slackens and the particle goes into a projectile motion and falls like this. Whereas if V naught is even less than or equal to root 2 GL, then it sways like a pendulum. Then what happens is that here the particle still has speed where the string slackens. But in this case, the particle will reach somewhere here with the thread being taut, but the speed of the particle will become 0. The tension will be mg cos theta. So it will behave like a pendulum. It will stop here and then it returns back along the same path. So it basically acts like a pendulum. Okay. So for V naught less than root 2 GL, the maximum angular position is less than 90 degrees. For V naught equal to root 2 GL, the maximum angular position it goes to is equal to 90 degrees. So basically, these are the three possible cases for the vertical circular motion of a particle tied to a string. Greater than root 5 GL, greater than equal to root 5 GL, so completes vertical circular motion. Less than root 2 GL, it behaves like a pendulum. But between root 2 GL and root 5 GL is that very tricky kind of situation where the particle goes up to a point and the string slackens. And from there it comes down, but via projectile path, because it has speed at this point. Okay. So you have to compare the given situation with probabilities, and you have to understand that which of them is happening for which of the values of V naught. Out of 30 and 20, in which case it's completing vertical circular motion, in which case the string might be becoming slack, etc. You have to gauge these things from the values. Okay, so let's understand this question in detail. So you can see that length of the wire or of the thread is given to us as 10 meters. So the value of root 5 GL is 10 root 5 meters per second. The value of root 2 GL is 10 root 2 meters per second. So this is approximately 14.1 meters per second. And this is approximately 2.24, sorry, 22.4 meters per second. Okay. So from this analysis, we can see that this value that is given to us, 30 meters per second, this is greater than root 5 GL. So in this case, what will happen is it completes the vertical circular motion. Okay. Whereas this value that is given, it is greater than root 2 GL, but less than root 5 GL. So in this case, what will happen? The thread will slacken or it will become slack at some position. So each case has to be treated differently. So what all we have to find? We have to find the maximum and minimum tension. So when you complete vertical circular motion, the tension will be maximum at lowest point and tension will be minimum at highest point. So we'll take care of that, what those tensions are. Okay. And the maximum height will be 2L. But in this case, because the string slackens, tension will be 0 and maximum tension will be at the lowest point. Okay, and maximum height it climbs to, we have to calculate. So let's work out each of these parts. So let's look at this in detail. When we are giving it an initial speed of 30 meters per second, for the length of this thread being 10 meters, we can see that our V0 is greater than root 5 GM. Okay. So this is how the path will look like. So if it starts from the bottom, with the speed of 30 meters per second, then at this point of time, the tension will be such that T0 minus mg is equal to mv square by L. That is at this point here. So tension at the lowest point will be mg plus mv square by L. So if we calculate that, the mass of the particle, I think I had given you as the mass was not given. Let's take some value of mass. Let's take it as 1 kg. That we can get the numerical answer for this tension. So 100 newtons is the tension at the lowest point. This will be the maximum tension. Okay. So as yet we haven't started the application of work energy. Now from here, as it goes to the highest point, at the highest point the speed will be minimum. So accordingly, the centripetal acceleration will also be minimum. So the tension will be minimum. So at this point, the speed is minimum. So accordingly, the tension is also going to be minimum. At the highest point, B is minimum and tension is minimum, and that T minimum plus mg is equal to mass into centripetal acceleration, that is mv square by L. So this equation we have to use. Okay. Now to use this equation, we have to find this V minimum at the highest point. So we use work energy. From this lowest point to this highest point, conservation of mechanical energy. So half m into V minimum at the highest square minus V naught at the lowest square minus mgh, where h is this total height it's climbing. So that is nothing but 2L, should be 0. So from this we will get V minimum at the highest point as square root of B naught square, sorry, this plus because it's climbing through a height of, okay, so B naught square minus 2gh. So in this case, it is V naught square minus 2g into 2l. So let's substitute the values. So 30 square minus 2 into 10 into again 2 into 12. So square root of 900 minus 400. So that's 10 root 5 meters per second. That is a minimum speed. Okay. From this now we will get the minimum tension at the top. So it will be 40 newtons. This will be the minimum tension at the topmost point. Okay, so hope this question is clear. Now let's come to the second part. When we give the speed of 20 meters per second, which is less than root 5 GL. So what is happening is V naught is less than root 5 GL, but at the same time greater than root 2 GL. So what will happen to the particle is that it will come to some angular displacement of more than 90 degrees, somewhere here, let's say. So when it comes to this position, the tension in the string will become zero, because the speed is sufficiently small that if this angle is theta, mg cos theta is becoming mv square by L. And then apply work energy between this point and this point. So you can see that this total height is L plus L cos theta. So this becomes our second equation. So solving these two, we will get the required condition. So from equation 1, we have V square is equal to GL cos theta. So substitute this in equation 2. Now put the value of GL as 10 into 10 or 100, and V naught square as 20 square or 400. So 100 cos theta is equal to 400 minus 200 into 1 plus cos theta. So cos theta is equal to 4 minus 2 into 1 plus cos theta. So 3 cos theta will become 2. So cos theta here is again 2 by 3. Theta is cos inverse 2 by 3. So the speed at that point is 10 root 2 by 3. So first of all, we can see that the maximum tension is much at the lowest point. So 50 newtons is the maximum tension. And minimum tension is 0 at theta equal to cos inverse 2 by 3 as shown. That's one thing done. And now we have to find the maximum height to which the particle climbs. That is not going to be this h, because after this it goes into projectile motion. So we'll also have to solve the projectile motion part. So we'll come to that. But first make sure you understand this. Okay, now let's understand how we'll calculate the maximum height to which the particle rises. So we've already seen that given this 20 meters per second, the string slackens at a position like this. Where this has cos inverse 2 by 3, and at that point of time the particle has a speed v like this. So this speed v will also be at an angle of theta to the horizontal, which is the same, because after all this is the tangential direction, so it is at 90 degrees with respect to the radial direction. Okay, so from this point onwards the motion is projectile motion. So it climbs to this height here of v square sine square theta by 2g. Now we had already seen the formula that b was equal to root gl cos theta. This we had already seen actually. This was the speed at the point where the tension became zero. This is the point where the tension becomes zero. So this maximum height of the projectile motion, this will become 10 root 2 by 3 whole square into sine square theta, which we can write as 1 minus cos square theta upon 2 into 10. So 100 into 2 by 3 divided by 20 into 1 minus cos square theta. Now remember cos theta is 2 by 3. So 100 by 30 into 1 minus 4 by 9, or 10 by 3 into 5 by 9, or 50 by 27 meters. This is the maximum height of the projectile motion. So hence from the starting point, as the particle falls, what is the maximum height it achieves? This is going to be that maximum height. That maximum height will be this height h, which we calculated earlier, plus this one capital H. So this will become the maximum height. 50 by 3 plus 50 by 27. You can calculate that. So approximately 18.47 meters. This is the maximum height to which the particle will climb from the initial position from where it started. Okay, so bit of a lengthy calculation, but this is how you do it. Okay, now we'll come to some of the doubts that students have sent. So, for example, I've received a request to solve a question from the module exercise 2 level 2 question 31 from Kshitij. So I'll start with that. So I'm switching to the module exercise. So we'll go through some of the questions in this which are doubts. We'll start with this one, 31st question. Go through it, I will explain. So it says a wind powered generator converts wind energy into electrical energy. Okay. Assume that the generator converts a fixed fraction of the wind energy intercepted by its blade into electrical energy. So for a wind speed of V, the electrical power output will be proportional to which of the following? V or V square or V to the power 3 or V to the power 4. So try to understand the question first. I will explain what is the approach we will take. So if you're converting wind power into electrical energy, so first of all, what you're doing is you're converting mechanical energy into electrical energy. And that to mechanical energy of which type? So if you think about it, wind is basically what? Wind is air molecules which are in motion. Okay. So what type of energy wind possesses? It possesses energy by virtue of motion or kinetic energy. So basically, we are not only converting mechanical energy, but we are converting mechanical energy in the form of kinetic energy of the wind, or the kinetic energy of the moving air particles and air molecules that constitute the wind, that is being converted into electrical energy. Okay, so the electrical power output is the rate of energy converted per unit time. So we have to understand that that rate of electrical energy per unit time that we are getting is going to be a fixed fraction of the rate of kinetic energy that the wind is providing per unit time to the moving blade, the blade of the wind converter. So how we will relate that with the speed of the wind? That is the thing we have to calculate. Are you understanding, Kshitij? Okay. Kinetic energy is getting converted to electrical energy. So the rate at which kinetic energy of the wind is captured by the blade will be proportional to the rate at which electrical energy is created, or this output of electrical energy per unit time. Is the question clear? Okay, so let me explain. Good. So let me explain how we will do the calculation further. So first of all, the electrical power is equal to some fixed percentage. So let's say that is N of the mechanical energy per unit time. Mechanical energy is also in the form of kinetic energy actually per unit time intercepted by the wind generator, the wind power generator. Okay, so that thing where N is a fixed fraction. So we can say that the electrical power is proportional to the kinetic energy per unit time captured by the wind power generator. Okay. So now imagine air particles are moving in this direction with a speed v, and they are intercepted by the blade of one of the fans. So the blade's area is A. Okay. Then in a time dt, and the density of air is d. So then in a time dt, okay, the mass of air hitting the blade or colliding with the blade will be how much? It will be density into area into V dt. Why it will be into V dt? Because see, a small section of wind of air in front of this blade that goes and hits this blade in time dt will have a thickness of V dt, na? Because a small displacement in this direction is equal to V dt. Na? So this will have how much volume? The volume of air that hits the blade will be area into thickness. So volume into density will be the mass. Is this equation clear, Kshitij? So in time dt, the mass of air that is hitting the blade is this much. Blade of area A. Hai na? So therefore, in time dt, the kinetic energy, okay, incident on the blade, that is a differential amount, that is this much, half dm into v square, where dm is this much, so that is half density into area into v dt into v square. So the power, electrical power generated will be some fixed constant n into the rate of kinetic energy per unit time. This kinetic energy per unit time, you can think of it like this. So it is n into by dt. So it is that fixed fraction into half rho a v cube. So you can see that the power output is proportional to cubic term of velocity. So hence the answer should be it's proportional to v cube. It's a very interesting and technical question. Hope this is clear to you. Okay, next up we will do this question from exercise 3 of the module, question number 5. Just go through this question next, I'll explain it. So the next doubt I'm solving is exercise 3. This is on page number, just verify the page number for you. Yeah, page 127. Question number 5 on page 127. Sorry, just a minute. I've got the wrong question. Let me just a moment, people. I'll get back to you. Yeah, so let's solve this question. This is page 127, exercise 3. So just go through the options we'll discuss. Okay, so this is a very easy question, but the only thing is you have to mix the concepts of work energy and Newton's laws in this. Okay, so if you're pulling with a force F at the end of the thread, as you know, the tension in the thread will be equal to F because it's a massless thread. So T will be equal to F, will be equal to 40 newtons. That's the first thing. So you can see that the tension in the thread will be 40 newtons. So therefore you can see the acceleration of the block will be 40 minus 20 is equal to 2a. So it will have an acceleration of 10 meters per second square upwards, the block. Okay. Mass is given to you as 2 kgs. Force is 40 newtons. G we have to take as 10. Now in a certain interval of time, the kinetic energy increases by 40 joules. Okay. And it started from rest. That is also given to us in the question. So the kinetic energy became 40 joules, then half mv square is equal to 40. So V is equal to square root 40. Okay. Or you can also use this, that V square is equal to 2as. So the displacement is equal to how much? V square, which is 40, divided by 2a, which is 20. So the displacement will be 2 meters. Okay, so this is also correct. So if it started from rest over here, then by the time the displacement is 2 meters, its velocity would become root 40. So its kinetic energy would become 40 joules. So this is correct. Okay. So now what about the work done by gravity? So the body is making a vertical displacement of 2 meters. So the work done by gravity will be minus mgh. So it will be minus of 20 into 2. So minus 40 joules. So this option is also correct. And what about the work done by tension? The tension is acting vertically upwards and the displacement is also upwards. So that will be T into S. So the tension was 40 newtons. The displacement was, so it will be plus 80 joules. So that's also correct. Oh, sorry, the third option is wrong. It should be minus 40 joules, not minus 20 joules. The work done by this thing, work done by gravity is actually minus 40 joules, whereas this option is correct. Work done by tension is plus 80. That is why you can see that the change in kinetic energy is the net work done. So that is 80 minus 40. So it is 40. So hope this question is clear, people. Prince, you have any doubt in this? Okay, let's pick up the next question in our doubts. Okay, so same exercise, question number 9. So I'm just sharing the question. So in fact, it's on the same page, page 127 only. Question number 9 we will discuss, and then again we will discuss question number 11. So next up, this question, just go through it. Okay, so anybody got this question or got an idea how to solve it? See what is happening. The potential energy of a particle of mass 1 kg, it obeys this principle. Okay. So if the particle is at rest at this point of time, then what can we say about the acceleration of the particle? Okay. And when it crosses the y-axis, what can we say about the speed? So basically we have to find the path of the particle because we want to find the coordinate, the speed and all this. So we have to apply work energy theorem, but we also have to understand the direction of its motion. So we have to talk about force. Okay. So how we will relate when potential energy is given to us. So we'll understand that delta U is negative of work done by internal conservative force. This is the concept that we use in this question. So change in potential energy is equal to negative of work done by internal conservative force. This is the concept we will begin with in this question. Okay. So let me switch my board and explain to you what I mean by this. Okay. So in that question, which is basically question number 9 of exercise 3 again. It is given that potential energy is equal to 3x plus 4 by, okay, for position x comma y of a particle whose mass is given to us as 1 kg. Okay. And also it is at rest at the position 6 comma 4 initially. Okay. So from this, let us first understand about the force. Okay, the internal conservative force. So we can see that delta U is negative of work done by internal conservative force. So it is minus of F dot ds integration. So here the force will be two dimensional. Okay, and the displacement will also be two dimensional in general. So we can see that 3x plus 4y is equal to minus of fx dx plus f by dy integrated from 0 comma 0 to x comma y. So from this we can understand that negative of fx dx integration is 3x. That means fx is minus 3. And negative of f by dy from 0 to y is equal to 4y. That means y component of force is minus 4. So that's it. Now we have understood that the force is constant and we know its magnitude and direction. We know that the force is minus 3 I cap minus 4 J cap. This will be the force in newtons because this was the potential energy in joules. Okay, where xy was in meters. The units are SI units. Okay, and the mass of the body is 1 kg. So the acceleration of the body is force divided by mass. The acceleration is minus 3 I cap minus 4 J cap in meters per second square. So this is the first thing we can do. We can find out the acceleration, and first of all, we can answer all the options which are related to acceleration. Then we'll also answer the options related to speed and at which point it crosses the x-axis and all that. So I'll bring you back to that, those options also. But first of all, from the information given about potential energy and mass of the body, and that is a two-dimensional motion, using this relationship that delta u is equal to minus f dot ds integrated. Okay. So u at some general xy minus u at 0 comma 0 should be minus of f dot ds integrated from 0 comma 0 to x comma y. So this term is becoming 3x plus 4y. So that is my minus of integration fx dx plus fy dy from 0 comma 0 to x comma y. This thing I'm utilizing here in these steps. So just go through this carefully once. No, if we take 6 and 4, then we have to take some initial value of potential energy is different. We can solve the question that way also, but then we have to take, instead of 0 comma 0, if we take 6 comma 4 as the initial position for solving the force part, then there will be some initial value of potential energy also. See here what is happening, because we have taken the initial point as 0 now. The initial potential energy is 0 now, and this is the final potential energy. But if we had taken the initial point as 6 comma 4, then when we solve for this part now on this side, we would have had potential energy at xy minus potential energy at 6 comma 4, and this would not have been 0. This would have been 6 3s are 18 plus 4 4s are 16. So this would have been 34 joules. So we would have had uxy minus 34 is equal to this integration. So this would have been a little bit lengthy to solve. It would have given us the same result for force, but it would have been a bit lengthier to solve. Okay, so hope the logic is clear why I'm taking the initial point as the origin for the calculation of potential energy and force relation. Then I will treat this like a separate part. This is not potential energy, this is speed. Okay, one thing you have to understand, this is speed. This is not capital U, this is small u. You can just write this as V only. Speed is 0. So at 6 comma 4, we know the potential energy is 34 joules, but the kinetic energy is 0, starting from rest. So from that, we have to understand how it's going to move. Okay. So let's come to the various options. So from this now I know that the particle has constant acceleration. The particle has zero acceleration is wrong because we had got the acceleration to be minus 3 I cap minus 4 j cap in meters per second square. Okay. Now we have to check out these two options. So for that we have to understand the motion, that the particle starts from rest from somewhere here, let's say 6 comma 4 pe, its initial speed is 0. Now what about its acceleration vector? Its acceleration vector is minus 3 I cap minus 4 j cap. Okay. So its acceleration vector will be something like this. This will be the acceleration vector. So it will go in a path like this. So you can see that since the acceleration has an x component of minus 3 and the initial x component of velocity is 0. So the x displacement as a function of time will be minus 3 by 2 t square. And since the y component of acceleration is minus 4 and the y component of initial velocity is 0, so the y component of displacement will be minus t square. And the y component of velocity will be minus 40, like this. Okay. So when the particle crosses the y-axis, so when it crosses the y-axis, the y component of displacement should become how much? Minus 4, because it started from y equal to plus 4. No? This is not the coordinate. This is the component of displacement. This is the displacement x I cap plus y j cap. So if it started from 6 comma 4, okay, so that means y is equal to 0. Oh, sorry, where it crosses the y-axis, the x coordinate should be 0. So this point has x equal to 0 and some y coordinate. Okay. So at that point, the x coordinate should be 0. So to x equal to 0, what is the x component of displacement? That should be minus 6. So the time should become 2 seconds. So it crosses when the time is 2 seconds. So at time t equal to 2 seconds, you can find out what is the speed, because Vx will become minus 3 into 2, so minus 6, and Vy will become minus 4 into, that's minus 8. So V will become square root of Vx square plus Vy square. So that will become 10 meters per second. So this option is correct. You can also do this by work energy. I'll come to that also. Okay. And the coordinate of the particle at t equal to 1 second. Again, for that, you will have to use this. Okay. So I don't have enough space here. I'm going back to my whiteboard to explain this part. So now let's understand this thing, that in your coordinate frame, the particle starts from rest from a point which is 6 comma 4. So the particle starts from rest somewhere here. At t equal to 0, its initial speed is 0 at the coordinate 6 comma 4. But it has a unit, and that acceleration is given to us. I mean, we have calculated that acceleration vector to be minus 3 I cap minus 4 j cap in meters per second square. So the particle will have this kind of straight line path. It has this kind of straight line path. So its displacement at any point of time is, now let's use delta x instead of x. So if its displacement has these components, delta x will be minus 3 by 2 t square. Delta y will be equal to minus 2 t square. And at any point of time, if it has a velocity v now, its velocity vector will be vx I cap plus vy j cap, where vx will be minus 3t, vy will be minus 4t. So this is how it is moving with respect to time. Okay. So at some particular time, if it reaches here, okay, you can see that when it crosses the y-axis, its x coordinate is 0. So the change in its x coordinate is 0 minus of 6. So minus 6. So minus 3 by 2 t square should be equal to minus 6. So time should be equal to 2 seconds. And from that, you can also see that the change in y coordinate is going to be minus 2 into 2 square. So minus 8 meters. So my final y coordinate will be the initial y coordinate, which was 4, plus the change in y coordinate. So it's going to be 4 minus 8 or 4. So this point where it crosses the x-axis, it will be 0 comma minus 4. Minus 4. Okay. So you can also see that its speed will become 10 meters per second, because at t equal to 2 seconds, Vx is minus 6, Vy is minus 8. So V is square root of Vx square plus Vy square. So it's 10 meters per second. This one thing. And the other option we had to check was, we had to check the coordinate of the particle at t equal to 1 second. Okay. So this is where it is at t equal to 2 seconds we saw. So we have to also figure out that where it is at t equal to 1. So let's say it's somewhere over here at t equal to 1 second. So what are the coordinates? Okay. So t equal to 0 pay, it is at 6 comma 4. T equal to 1 pay, it is at some x, y, which we have to find out. Now delta x is minus 3 by 2 t square. So in 1 second, it is minus 3 by 2 or minus 1.5 meters. And delta y is minus 2t square. So in 1 second, it is minus 2 meters. So you can see x will become 6 minus 1.5. So that is 4.5 meters. And y coordinate will become 4 minus 2 or 2 meters. So therefore, at t equal to 1 second, its position will become 4.5 comma 2 in meters. So that verifies the other option also. So this is a typical JEE advanced level question, because it's more than one option correct type MCQ questions. They're obviously going to be a little bit more tricky, and in the same question you have to use concepts from work energy as well as kinematics or Newton's laws or whatever, as you can see. So anyhow, these are some of the more tricky questions in the module exercise. So you can please continue working on the module questions. But next lecture we will be starting with heat and thermodynamics. We are done with work energy, and you can continue discussing the doubts during mentorship or doubt sessions in future. Okay. So next topic we will discuss. We will start with the section of physics called heat and thermodynamics. And in that we will start with the first chapter, which will be thermal expansion. Thermal expansion of materials. Okay. So that's it for today's session, people. Wish you all the best.